Hi everyone, today we are going to discuss parabola. Now kindly check your module so that you can follow me. So in your module it is already stated there the different parts of the parabola. So we have the first one, we have the vertex of the parabola, the focus, the directrix, the focal width. We have also the parabola, which opens upward and downward. So let's try first to discuss the standard equation of a parabola with vertex at the origin. So we will be considering first vertex at the origin. The first thing that we are going to discuss is when the parabola with standard equation x squared is equal to 4ay. So if this is the case, when a parabola with standard equation x squared is equal to 4ay, it has the y-axis as its principal axis, the vertex at the point of origin, and the focus at 0, p. Kindly check your modules because you have that already. So first we'll have an example. So let's find A, the principal axis, B, the vertex, the focus, the directrix, endpoint of the focal width, and the length of the focal width. And then the last thing to do is to sketch the graph. So for example, we are going to get A, B, C, D, E, F, G when the equation is x squared is equal to 12y. Okay, so let's try focusing our attention here in this example. So letter A, we are going to take the principal axis. So what is the principal axis? Since the form of the equation is x squared is equal to 4ay, which gives rise to a parabola with y-axis as its principal axis. So our y-axis would be our principal axis. Okay? Because our equation is with x squared is equal to 4ay. Then letter B, what would be our vertex? Since the vertex is at the point of origin, so if it's in the point of origin, our vertex automatically would be 0, 0. Letter C. So letter C, what would be our focus? So the focus is with the equation 4a. So 4a, which is equal to 12. Therefore, a will be equal to 3. So consequently, the directed distance of the focus from the vertex is 3 units. This implies that the focus is 3 units above the vertex, having a corresponding coordinate of 0, 3. Okay? So this is our coordinate of the focus. Then letter D. Letter D, what is its directrix? So we know that the directrix is above or below the focus. So the directrix is a horizontal line, which is A is equal to 3. So meaning it's 3 units below the vertex. So the vertex is given by the equation y is equal to -3 because it's 3 units below the vertex. Then letter E. What is the end point of the focal width? So the end point of the focal width. Since the distance of the focus from an end point of the focal width is, we have 2a, therefore 2 now times our a, which is 3, it's equal to 6. Moving, we have 6 units to the right and 6 units to the left of the focus. Therefore, the endpoints of the focal width would be negative 6.3 and positive 6.3. Then letter F. What is the length of the focal width? So the length of the focal width is given by the equation 4 times A. So we have 4 times 3, that is now equal to 12. Okay, so let's try plotting now or sketching the graph of our parabola. Let's sketch the graph of our parabola. So let's say this is our graph of the parabola. Okay, so our vertex is at the point of origin. So this one here is our vertex, which is 0, 0. Then next we have our focus. So the focus is positive 3. So this is our y, this is our x. So we told a while back that our principal axis is our y-axis. So it's here. We have the focus is positive 3. So 1, 2, 3. This is our focus. So our focus would be 0, 3. That's the coordinates. And then we have also our directrix. So our directrix, that is y is equal to negative 3. So it's here. Y is our this is our focus. So this is our directrix. The coordinates is, we have x is 0, y is negative 3. So I'll be putting it like this. This is our directrix. Okay, then afterwards we have also the focal width, which is positive 6 and negative 6. So the focal width would be 1, 2, 3, 4, 5, 6. So this is the end of the focal width. So it's there, here, and on the other side 1, 2, 3, 4, 5, 6. So it's here also, there. Okay, so this will be our focal width there. So if we're going now to connect this one and form a parabola, so it would look like this. There. Okay, so that is our parabola. Then afterwards, we know now that the the length of the focal width is equal to 12y. So we will be counting now the distance. So we have, here is 6 units. So 1, 2, 3, 4, 5, 6, and on the other side we have also 6 units. 1, 2, 3, 4, 5, 6. That makes it 12. Okay, so that will be our first example.